the one that we're going to, if you notice, your dots are not, obviously labeled on your graph. I do apologize for that, so that's why we're obviously going to go through graph A together. That'll be part of your notes, okay? So, if you would, on this first graph, I'm going to take you through the steps. I'm going to talk to you about, first of all, we're going to remind everyone in just a minute how you tell if a graph is proportional or not. We're going to talk about what's the difference between a function equation versus a proportional equation. We're going to talk unit rate again from a graph. Hopefully we remember all this. So this is kind of refreshes our memory of what we did last week. But last week I believe I gave you tables and I had you make graphs, create the graphs. This week we're going to go backwards. I've given you the graph, and now from the graph, can you pull information from the graph to answer questions? So this week, that's what we're going to concentrate on, all right? And we're obviously going to put everything together that we've done so far, okay? So hopefully you have this out. Everyone with me? If you want to, you can label the points that I have up there on your graph. That makes it easier for you to see. Otherwise, let's just look up here. First of all, number one, the question asks, is this a proportional graph? So first of all, how would you respond to that question? What does your instinct tell us, Ben?
Yes.
Why is this a proportional graph? How do you tell?
It's a straight line and it's connected to a base.
So you're telling me that a proportional graph has to be a straight diagonal line, and what else does it have to come in contact with? Caitlin?
The origin.
Yes, and you guys remember that we talked about how these graphs, you guys agree this is only quadrant 1 that is shown here, which means, remember, this line keeps going. Think about a line. It doesn't go infinite in both directions. Okay, they just cut off part of the line because does it make sense to have negative calories and negative snacks?
No.
I wish for the negative calorie part. That would be nice. Sweet. Okay, I wouldn't have to count my calories or exercise. All right, so is this proportional? Absolutely. And obviously, why is it? It's straight, it's diagonal, and it comes in contact with the origin. Now, number 2 and 3, they ask us, write the proportional equation, write the functional equation. Well, let's skip number 2 and 3 because number 4, I think they have this out of order. Because if you can find the unit rate, I believe these two will just, boom, they happen. So, does anybody remember how to find unit rate? Remember the hint I gave you last week about when we looked at graphs and we compared graphs and equations and, where you could find unit rates, Sasha?
You just circle a dot.
You can just circle a dot? Sure. What one's the easiest one if you have it given to you? Which one is the go-to if you got it? Remember the one point that you want x to equal this, and that'll give you your unit rate. Brian?
The dot that has the number 1 for snack.
Yeah. Isn't this your x? This is your x, correct? Isn't this your y? When x is 1, wouldn't that be your y over x? Your bottom denominator would be 1. So it's per snack. So do we have the point where x is 1? Ha. So if you use that, that's going to tell you your unit rate. So what is the actual ratio of that point on our graph? Charlie? Okay, so she said that our y over x ratio was 120 calories for one snack. So what's our unit rate? 120 calories per snack. Now, do you guys remember, how did we write our equations? Remember how we wrote our equations last week for our assignments from tables or graphs? So how could we use our unit rate to write an equation? What would be our equation? Y is equal to what? What does our y equal? Trey?
120.
Calories. No. Remember what operations can only involve in our equation if they're proportional? You're telling me this is a proportional graph, correct? Which means our equation also has to be proportional, so only these operations can be involved. So how do we write the equation using our unit rate? This is why we're reviewing this.
Y equals something x.
Yeah, what's our something? Our something has to be what?
120.
There you go. All right, now, So our proportional equation, all right, is this right here. What is 120 replacing? What variable? That's what we're going to use, because that is actually the function y is equal to kx is what we're actually creating. Function means graph, folks. Y is equal to kx equations make this type of graph. Y is equal to mx plus b makes another type of graph. Y is equal to ax squared plus bx plus c makes another graph. And they're all function equations. They're all different. When I talk about a function, it's the type of graph, okay, that it makes. The equation makes this certain graph. This equation makes this certain type of graph, and so on. Is that understood? What a function means? A function means the type of graph it actually creates of the relationship between your x and your y, which we're going to get to that. That's what the table gives us. You see the table right below the graph? Okay. Sometimes students, and why I always tell you that, remember last week I told you that the equation, the graph, and then the table of values is the trifecta of a function. Okay, you have to have all three components. Some kids like just to look at the equation to find the pattern. Some students like to see the table because I can see the pattern from a table, how it's set up. Some kids can look at a graph and go, boom, I got the pattern. Do you see? That's where you, knowing who you are, which one do you like the best? And that's where your go-to. You're going to find yourself like going more toward, I need to see the graph. So you would obviously graph the table. Or you can just look at a table and go, got it. Well, I got a graph. I'm going to make a table so now I can see my pattern. And that's what we're doing today. So that if you're that type of student and you're given a graph, could you make a table so now you can see the pattern a lot easier? Yes. That's what I want to make sure of, is that no matter what I give you, you can use the table, make a table if you need a table. You could actually use the graph that's given to you. If I give you an equation, could you create a table of values to use if you need to? It all depends on what type of person you are, what kind of student you are. I'm going to be honest, it's been a long time since I sat in a chair, in an Algebra 1 classroom or, math classroom, but I do remember that I was more of a picture person and a visual person. I need to see it. So I was more of a graphical, I need to graph it, okay? And I also, depending on the time, it was algebraic was also my go-to, because I did a lot of things in my head. You know who you are that likes to do that. Most of you in here like to do that. You don't like to show your work. Guilty.
Nope.
Mm-hmm. You all are guilty of that. All right, so from this, what I want to do is go to the next one. So what if you have a graph? Here's your graph that I just pulled off to the side. Come on, little guy. Come on. Here we go. All right. Here's our graph from the. I just had to paste it again. So here's our graph. Now from this graph, could we make a table of values if you needed to? You're just trying to prove to yourself you could do whatever you need to do to get to that information. So do you guys think that you could finish this table based on the graph? Sure you could. All right, so if I have one snack, how many calories is it again? Do you see how finding the unit rate, do you even need to look at the graph anymore to fill the table out? No. So do you see how, now you can see the pattern, okay? Because a lot of times I'd get that unit rate from the graph and then to fill out the rest of my table, I just use the unit rate. Because for every snack, aren't we going up 120 calories? Woo! So, this would be 120. What's 2?
240.
240. 3?
360.
360. And 4?
480.
480. There you go. Now, the next column says write them in ordered pair form. You guys okay with how an ordered pair is different between if I just gave you a table versus ordered pair? You know which one goes first in ordered pair form? One person knows? Olivia?
One at the x-axis, right?
Yeah, because remember that x always is, x, y, z, right in the alphabet? X always comes first, left to right. Just like a table. This is your x, this is your y, right? So, obviously, it'd be 1, come on, whoops, forgot there's 120, okay? And 2, finish that up. And then we're going to write them in words. Because there's times where they're going to ask you to find some point on a graph, and they're going to say describe it. What does that mean? What is 120 mean on that graph? What is 360 ordered pair? What does that mean on that graph? What is that describing to you as a reader as you see those points? All right. So with that, can I move this now? We don't really need this anymore, do we? No, we don't need it. So I just moved that off to the side. So if you notice, here's the first one in words. What does 0, 0 mean on that graph? Okay. Obviously it says 0 snacks have 0 calories. So I want you to write a statement with the relationship of snacks to the calorie intake for each pair of ordered pairs. So one thing that I told the other class, do you see how they write out 0? Let's have some proper grammar here, where if it's the first letter, if it's the first word here, if you're going to use a number for the first word, would you please write it out as a word? Okay? If the number comes after that, I don't care if you abbreviate it, but the first, you never put 1 snack. That's not how you write a sentence. Oh, Mrs. Holmes.
What if for a number higher than 100?
So could someone read a statement for 240? How could you, describe that point? What would you say that in words?
2 snacks has 240 calories.
Well, how else could anybody say it somewhere a different way?
240 calories is equal to 2 snacks.
You guys agree that there's a lot of ways you could write this as a statement? I mean, for every 2 snacks, it's 240 calories that you intake, I mean, there's lots of different ways. You remember those who are my fancy words when we did ratios? For every, there's, Some of us are just right to the point, like 2 snacks. You just, just make it simple. You don't have to complicate it. Everyone okay with this one? All right, turn to the page to the graph B, please. I want you to answer just the question number 1. And then raise your hand if you know what the answer is. Jonathan, what do you got? What do you think? So Jonathan says this graph is not proportional. If you agree with him, give me or the rest of the class a reason why. Why do you think Jonathan says no, it's not proportionate? Andrew.
Because it doesn't touch the origin.
Is it straight?
Yes.
Diagonal line?
Yes.
Yep. So the only reason why this is not proportional is because it doesn't touch the origin. Which means another operation is involved. So I believe this has to do with taxi cabs. Correct?
Yeah.
I mean, I don't know if you guys have ever traveled in a taxi cab, but when you hop in a taxi cab and you haven't even, the taxi cab driver has not even accelerated yet, on the little little machine that, tells you how much money, it already says an amount. As soon as he just resets it, it's always at a, remember when we wrote those 2-step equations? And remember North Point? When we had North Point, it was like a $35 registration fee. And then every month you have to pay a monthly fee. Remember that? Where you had to pay that. That's what this is. That has multiplication and addition in it. And I'm going to be honest with you. These right here are the largest function types of graph. Remember this. Functions are types of graphs. Okay? That you will ever come in contact with in a math classroom. You'll spend more time on linear functions. Anybody know how to spell linear? Think about the first 4 letters in linear.
Line.
All lines fall into linear function. So even our proportional graphs, aren't they lines? So they're under the linear function umbrella, but they're just a little small category right over here. Okay, there's, there are all kinds of different things. So what I'm telling you is you're going to see this a lot. So I'm just going to walk you through it, okay? All right. So, first of all, is it proportional? No, it's not. Okay. Describe in words the pattern. Anybody want to take a shot? Because there is a pattern. Trey, you want to try it? Go ahead. What do you have to lose? Go.
It goes up $1 every mile.
There it goes. Starting at $4, it goes up $1 from there every mile. You see it? Starting at $4. Does it go up $1 every mile after that? You see the pattern? So does it have a constant rate inside that line? Every line has a constant rate. For it to be proportional, it has to start at 0, 0. So if I took, what if I said the cab driver had started at 0, 0 when you got hopped in the cab? What do you notice about those two lines? What type of lines are those? Lainey?
Parallel.
Yeah. You know why? Because they have the same rate, constant rate. It's the fact that they start at different places on the y-axis. This starts at 4. Isn't this the y-axis here? This one just starts at 4. This one starts at 0. One is proportional, one is not. But they have the same rate. Okay? It's that flat, the flat fee, or if you say you start with $50 in your checking account or your savings account, and then every week after that you put $5 in for the next 3 years. How much money are you going to have at the end of the next 3 years? It's the same thing. Because aren't you going to constantly put $5 in? Aren't you going to stay at $5? It's going to raise $5 consistently every single week. There's a pattern. Okay? But you started with a big chunk. You deposit so much money at the beginning. So that your bank account didn't start at 0, 0. You started at, this much. Now, after that, now it raised the same constant. So, let me just show this to you. Can you write no, you cannot write a proportional graph, but you can write a function graph. Don't we start at $4? And what do we add every time? What did you say? What was our constant rate after $4? It goes up how much? $1. So watch. And remember, our unit rate is always the coefficient on x. So what would be 1x? What would that look like?
X.
Just x. That's what our equation looks like. Do you guys see where we say $4? We start at $4, and every time you're gonna add 1x. Okay? 1 times 1 is 1. 1 times 2 miles is 2. 1 times 3 miles is $3 added on. You see it? Now you see it? Okay? Those darn cab drivers. Some state in you go to all the ones I've ever been in was always $3. Any questions on that? All right, now can you fill out a table?
Yes.
So you're telling me we can fill out a table for any type of graph, right? Now, if you notice, let me just fill this in. Miles or cost, which ones are x? Do you guys agree that in a T-chart, your x is always on the left side of y? Just like how you write an ordered pair. So we start with 0, but what's our cost this time? 4. After 1 mile, what has the meter gone up to? 5. 2 miles? 3 miles? 4? All right. Write your ordered pairs.
The only half that's different is cash cow.
What does it start out at? Does it tell you the price?
I don't think so.
I don't think it does
You
either.
earn money.
You earn money on that one. Oh, that's right.
Doesn't it?
Is it every question you get right or something?
Yeah, it starts off at like 50
But
or
then if you
100.
get like the last one wrong, or you get like a certain amount of strikes, then you get kicked out.
Oh.
Yeah.
Okay.
That
You watch
TV
that
show.
all the time.
You want to feel like imagine if someone that was legit.
Okay, now let me explain what you're going to do. I want you to finish this at your own pace. If you would, can you look at the last 4 graphs, please?
Are we gonna finish this one?
Yep, you're going to finish that one. Now, do you guys agree that all the 4 graphs that you have left are proportional? Do you guys agree?
Yeah.
Okay, so let me give you a hint. In this first box, you're going to put x, y. And every single proportional graph starts where?
0.
0, 0. So all of your tables should look like that, and then after 0, 0, obviously, aren't they going to determine depending on your unit rate that you find? Okay? Now, What is the difference between a function equation versus a proportional equation? You guys notice that they ask you for both? You notice they ask you for both? You guys remember what? Look at our first page. Look at our first graph. How did we write our function equation versus our proportional equation? What's the difference between those two? One has this in it, the other one has this. Did you guys write it down? Remember, that's why you write notes. What did you write? What's your proportional equation have in it versus what the function has? Your function equation has what variable in it? K. So all your function equations should just be y equal to kx. Your proportional equation has what in it? Has the actual number that you replace k in, don't you? Okay, that's the difference. So I want you to finish this packet. This is the one that if you're, you should have this done. All right? Abby, you have a question, honey? Does everyone understand so far what the directions are? You're going to finish the table in graph B, the words. Some of you are still working on that. And then the four graphs. Everyone with me? Yes. Kx. And then the proportional, you actually plug in your unit rate. Yep. Because that's the function, that's the standard function setup. If you see that type of equation, it's always going to make a proportional graph. Now, if you would, can you look at the other packet, please? For those people who are not going to be with me tomorrow, you're going to Mr. Boland's room, right? Right? Okay. I'm going to tell them exactly what you need to do. This packet, the first page, front and back, is what you're going to be working on. Basically what you're going to do is they give you a graph just like they did on your first packet, correct? And then you're going to answer these questions from the graph. Now I want to ask you guys something. I want you to write something down on the front page just for a little, because you're not going to have me to give you hints tomorrow. From a graph, if you find this from the graph, you can answer any question from that graph. What is it? Think about how do we make the proportional? What do you need to have for the proportional equation? What did we practice finding on every single graph last week? We had to find this. Jocelyn, what is it? Find the unit rate. You can answer any of those questions. If you know how much it costs for the bike, right? Can you find for 12 bikes? 54 bikes? 60 bikes? Right? Does it matter? You can answer that whole sheet. Turn the page. You have two different scenarios. You have cost per bike, and then the other one, my favorite, the number of fish caught per boat. All time, one of my best hobbies. Love to fish. Okay? All right? So you're going to, again, what are you going to find from this graph before you answer any of those questions? What are you going to do? Find the unit rate. You're going to tell me, Mrs. Mullins, that it took me 2 minutes to do this worksheet. I go, I know. There's my hint. You can make it more time, or you can slip it down to what's valuable. Is your time valuable to you? Isn't it? All right. So I'm giving you that hint. You don't have. Some of you don't have me at your disposal tomorrow. But those people that have me that are going testing, you have this due on Thursday as well as everyone else in here. Okay, you stop there. Make sure you put it stop at the end of the fish. Stop at the fish. Do not go on. Okay? So you're just doing the bike graph and the fish graph. Then we're going to come back and do some Mario and Luigi. We're going to compare. We're going to do some Best Buys on graphs. The tortoise and the rabbit on a graph. Okay, so we're going to compare things with two graphs on the graph. And that's where we end this week. So we have to look forward to. Do you remember on the park test where you had to plot 5 different points at the same time? Or 4 different colored points? Okay? So we're going to do some comparing and contrasting, showing you how to do that. All right? Gavin, what you looking at me like that for? All eyes on me? Awesome, I love it. Now, is there any confusion what your task is or what I'm expected of you by Thursday when you walk into class? Can you wait for the fish in the bike if you're going to Rollins and just work on it in there? Absolutely, why wouldn't you? Otherwise time is going to go, okay? Otherwise I'm going to tell them that if you're done, you can help his class out. Give you little tutors. You know what I mean? Good, good. Because guess what? Right now, I could use a little help if you have friends that are in my other classes with inequalities. They're having some difficulty, so I'm going to tell you, if you have a friend that's having difficulty, step up. You've learned open and close. They really don't understand that open and close thing, even though I've told them to write it down 100 times. Hey, sometimes, remember I told you, you guys learn just as much from me as you do from your peers. I think sometimes you learn better from your peers than from me. I think that some of you explain it in a way that you can, when you talk to your friend, you know how to explain it to them. It's amazing. You should hear some of your conversations. You're wonderful. I mean, some of you have a gift.
Sometimes we talk to our friends and we say something that regular people won't understand, but your friends will understand.
That's what I'm saying.
Yeah.
You guys, you have that connection on their level, and that's what I'm saying. I'm not saying I'm above you at all. Absolutely not. I'm just saying that sometimes how I explain it necessarily, I don't have everybody on the boat. You know what I mean? I don't have everyone with me. And if I could just get that little different perspective, and I know you guys have already gone through it, you've already got that experience, you've already worked out the kinks, that, if you have a friend that's in dire need, don't hesitate to help. Don't just give them answers, but maybe explain to them, what do you need to do? Why is the arrow going left versus right? That's where they're having trouble, like they don't know. But it would help if they knew their inequality symbols. I even taught them the L. Remember the L?
That's what
Squeeze? Yeah. Anybody else? Is there anything else in inequalities you can remember? I gave you a trick to help you. Does anybody remember? It may be helpful. If you can remember that, like, you know what I mean? Like, you guys remember? Yeah, so you already have your assignment, so you don't have to go by me because you don't have, you can't write it. Because I'm going to get some information. So just want you guys to have it. So you're all ready to go.
Yeah, it is.
Anybody?
Yeah, it should be because we had all.
So you're not
The
ready.
first grade teacher
Oh, no, I can do that. Everybody else got their bell work from last week that they didn't have done and they need to hand it in.
I only have
Books are so easy.
I got books.
I got a book, but one of the book was 20 pages. No, I got 30 something back. Still getting it.
Yours
I didn't get that book.
The thing is, I forgot last.
Is that what you're asking?
I want to make sure it's an action. I just wrote my I wrote things with pretty fair.
Yeah.
So it'd be like the founder, Danny Thomas, was born in 1939 in Philadelphia. Sam was born in that decade. And then Sam was born in that
What is today? What?
Oh.
Hey, guess what? Number 3. Bye, guys. See you guys. Come find me if you have any questions. Tomorrow's your hour or Wednesday or Thursday's your hour, okay? Alright, you guys. Bye, guys. Huh? I know, you have to put up with me, Trey, for a couple hours,
Matthew Nowicki to the office, please. Matthew Nowicki to the office.
Get your notes over here, guys, please.
Can't wait to see the loophole. Okay.